Hello scholars, here we are with a video review of your quiz. Here we need to write two inequalities to form a system of inequalities. And we're going to graph it to look for the overlap to see if we can decide what are the possible combinations of toothbrushes and toothpaste tubes that JJ can buy. First job is to pick some variables and write for me what they're going to stand for. If you don't write down what they're going to stand for, then halfway through this problem, you will mix up your toothpaste and your toothbrushes. Guarantee it. So I've written down, I'm going to let X stand for the number of toothpaste tubes he buys, and Y stand for the number of toothbrushes. And the idea here, I think what stuck people was these two constraints. JJ buys at least 20 items, and JJ spends at most $50. They don't directly translate from English into math. So I just want you to think about when we write an equation to model something, most of the time, almost all the time, you can kind of think of it as a scenario where the sum of the parts equals the whole. In this case, we're talking about inequalities. So we know that the sum of our parts, in this case, for the number of items he buys, is at least a total of 20. So when I think about that first constraint, I might write myself a note. If you don't feel like you're ready to just translate from the words of the problem to the math, so I might write sum of parts equals the whole. In this case, the whole is the 20 items he's going to buy. And I know that the two parts here are the number of toothpaste and the number of toothbrushes. In this case, that's not going to be equal to 20. He buys at least 20 items, so that's going to be greater than or equal to 20. And if I have this written down, now I can translate directly from English to math, because I already said that the number of toothpaste he buys is going to be X, and the number of toothbrushes he buys is going to be Y, and I know that's going to have to be now greater than or equal to 20. So that's going to be the first of my inequalities. X plus Y is greater than or equal to 20. Now I'm going to go back and I'm going to write myself a note about the second constraint. It turns out it's another case where the sum of the parts equals the whole. In this case, the sum of the parts is greater or less than or equal to the whole, because we have a maximum total that he can have of $50. Another thing I noticed some students mixed up when you were writing your inequalities, 20 is a number of things he buys, and things that qualify as things are toothpaste tubes and toothbrushes. So when we add things to get a total, they have to have the same units. So things are toothbrushes and toothpaste can add together to compare to the 20 things. But when I compare to the $50, I'm going to have to add up amounts of money. So it's going to be like the total he spends on toothpaste plus the total he spends on toothbrushes has to be less than or equal to $50. So that's what I'm going to write here. I know the less than or equal to 50 part. And the two things he spends money on are toothpaste, which is $3 each, and he's going to buy X of them. So I'm going to write 3X is his toothpaste total. I'm going to add that to his toothbrush total, which is $2 for every toothbrush. And that's going to have to be less than or equal to $50. So now I have my second inequality. I'm going to line them up, and then I'm going to switch the screen around and show you how to graph. So these are my two constraints. I'm going to graph them and show you a little bit about what that looks like. Here, I happen to choose X and Y, and we have already we have an exact understanding of which axis is the X-axis and which is the Y-axis. If you had chosen different variables, which that's totally fine, but now it's your job to choose which one is going to go on the horizontal axis, which one's going to go on the vertical axis, and label it. And remember these things that I wrote down here, my definitions for my variables? Since X and Y are my variables, then what I've written here next to them, they're going to be my labels for those axes. So I recognize there's not a lot of room here. So on my x-axis, I'm going to label that with number of toothpaste tubes. And here, along the y-axis, number of toothbrushes. All right, so here we go. To graph these, I'm going to need to, well, I don't need to. I'm going to choose to change into slope-intercept form. Here, let's make this y is greater than or equal to negative x plus 20. And here, that's going to change to 2y is less than or equal to negative 3x plus 50. That's me subtracting 3x from both sides. Now I can divide by 2, and I'll get y is less than or equal to negative 3 halves x plus 25. Now I need to choose units for my axes. And if I'm looking ahead, I see that one line is going to have a y-intercept of 20. My other line is going to have a y-intercept of 25. And you might find that if you counted by 2's, so I'm going to count by 4's and skip a spot. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. I might have even been able to count by 1's and still fit this on the graph. Well, that's okay. So I'm going to, let's see, graph this first one in, oh yeah, I'll use blue and red. So I'm going to graph this inequality in blue. I'm going to start with a y-intercept of 20. I'm going to use the same scale. Shouldn't have done that. Okay, use the same scale on these axes, 12, 16, 18, this is going to be 20. I already know if I have a y-intercept of 20 and a slope of negative 1, I'm going to have an x-intercept of 20. I have an or equal to sign there, so I'm going to make this a solid boundary. And I know he's going to buy greater than or equal to 20 items, so I'm going to mark that boundary line, and I'm going to shade above that boundary line. The second inequality I'm going to mark in red. I'm going to start with a y-intercept of 25. A little bit higher than my 20. I'm going to come down 3 over 2. Since I have the same scale on both axes, I can just count boxes instead of trying to like remember that I counted by 2's and use half a box for every one. So this is going to be down 3. Over 2. And go down 3 over 2. If you figure it out, I think it intersects somewhere about 17.5. And I know he has to spend less than $50. So now, all right, tricky to do on my screen. Thank you for your patience. The question is, where's the overlap? So where did I shade above the blue line and also below the red line at the same time? I can come back in here and, at least for the way I chose my variables and chose my axes, this is the overlap. That's the part that I'm expecting you to notice and highlight when I ask you to graph a system of inequalities. So there was another question, which was, could JJ have bought 5 toothbrushes? So I'm going to ask you to notice, you could have tried to make it work in the wording of the problem, which is totally fine. I want you to notice, though, that if I go to the place where my y represented the number of toothbrushes, and here's where y equals 5, were there any colored dots on that line where y equals 5? There weren't. It's not in the overlap of the system of inequalities. So you could make it fit. Could he buy more than 20 items after buying 5 toothbrushes? Yeah, but you'll find it doesn't fit in the other constraint, which is the number of toothbrushes. I mean, doesn't fit in the other constraint, which is he has to spend less than or equal to $50. So 2 good ways you could have answered that question. Nobody actually used the graph, so I want you to be able to think about that. If it's a solution, then it has to be somewhere in the overlap of the graph. And then my last question, why did I only give you the first quadrant to graph in? Because the 2 variables, the 2 quantities that we don't know, the number of toothbrushes he buys and the number of toothpaste tubes he buys, have to both be non-negative. So it only makes sense to talk about solutions that occur in the first quadrant. I'll do question 2 in a second video.